Hi there, this is the first devlog of my Godot Roguelite fantasy strategy party RPG called Epic Exodus. I just started working on it last month, so this is kind of a pre-alpha, but maybe some of the techniques I'm using will help some of you who are working on a similar game or want to start on a game like this. This is where the game starts. You are building your initial army from a selection of characters. You have to choose at least 3, so the army is valid. And all these characters are from one of 7 different races of the fantasy realm. They have different attributes you can see here, and they have also a profession and 1 to 5 traits. Not all of them are known to the player from the start. These different races have relationships between each other. So if you choose, for example, an orc and an elf, or an orc and a dwarf, they are not very fond of each other. So there will be frictions internally in the army. The matrix I use to determine faction relations, where 0 is just a placeholder, and the relations range from 0.1 to 1, where 1 is a very good relation that don't have any strain on the unity of the army. Orcs, for example, have a strength range from 50 to 70, but also can push above or below that range with a value of 10 to make it a maximum strength of 80 or minimum strength of 40. But there's only a 5% chance of rolling these extended limits, which can make these characters more unique. The benefits of this feature are very apparent when you go to an attribute like Belief, where orcs usually have 0, so the normal range is 0 to 0, but they can have a belief from 0 to 100, but only with a 2% chance. So 1 of 50 orcs only is rolled with some belief. Then there are professions. For professions, I have a large list, but each race has a blacklist. These are professions that this race cannot have. Then there are uncommon professions. These are professions that are unlikely to occur in a race but can occur. For example, for an orc, a healer or an architect or an oracle are very low chance. And there are common professions. For an orc, this would be mercenary, executioner and gladiator. These are very likely to appear. All professions that are not mentioned in those blacklist, uncommon lists or common lists are distributed with a normal distribution. Same goes for traits. Blacklisted traits like altruistic, charismatic, sexy. For an orc, this cannot happen. And again, uncommon traits and common traits, which would be arrogant, courageous, stoic, assertive, mean, grumpy, loud, what you expect from an orc to have. So I pick some random guys for my army. That's my army with the blue flag, and the enemy army with the red flag for testing. I spawned them there. I was fortunate to find a kind of a table plugin for Godot that has sorting. The enemy army will attack me if I stay in this tile, so I'll click on idle to stay there, and this will make it attack me. Now we enter battle mode. What you see here are the enemy soldiers. They are square objects, and my soldiers listed to the left and also on the bottom as circles. By default, you see the class. There's a melee class, a range class for range combat, and a magic class that does magic combat. Now, by default, these are all melee soldiers because there are so few of them. I'll show you an example later that has also ranged soldiers. I can also switch to a different view which shows the race. That would be troll, an orc, and humans. For the enemy army, you won't see any names. This will just say troll, orc, or human, because these characters will not be generated like full player characters. You can also see the hit points ranging from red to green. These are absolute hit points, not a percentage. So humans, for example, who have low strength and low toughness have low hit points by default. So even a human who has maximum hit points for a human will still be red or orange, while only trolls can achieve a full green. When starting the battle, the armies will march towards each other until they make contact, and then they will start. Right now I'm logging a lot of debug information for my combat algorithm. In the final version, of course, you won't see these debug messages, but only messages that are relevant to the player. This is how I determine the strengths of the soldiers, so the melee rating, for example. So the strength puts a cap on the melee rating and is the main factor in the melee rating, but also toughness and agility will play a role, a lesser role. For the ranged combat rating, the dexterity determines the cap and also is the major factor in the formula. Agility and strength play a smaller role. And for magic combat, of course, magic determines the cap, and magic is the main contributor, and belief and intelligence play a lesser role. All that is multiplied by the base combat factor. The algo feedback is a system I implemented so the user can get more feedback on what the algorithm is doing in the background, because this gets very complex and there are a lot of interdependency, and as a player you want to know what impact your traits, professions, attributes have to your final combat rating, amongst other things. So I'm building a system that tracks all the calculations I do and stores them in a format that can later be parsed and displayed in tooltips so the player has an immediate idea of what's going on. I will show that system in more detail in my next devlog. For now you can see the combat rating is influenced by professions like mercenary, knight, gladiator, monk and paladin, where monk has a negative impact, all the others are positives. And for traits, courageous, lucky, mean and wise are positive impacts, where pacifist is a heavy negative. Here's a battle with a bigger army. Now you can see there's an additional class that makes the back row of my army, and this is ranged fighters. And when the combat starts, these ranged fighters will start to shoot arrows on the enemies immediately. An important feature here is the red line. All my games have red lines, so this was inevitable. You play this game going east. You can go up, down, left, right. The map is infinite in all directions, but your morale is constantly dropping. Only by crossing the red line will you get a morale boost. And if the morale reaches 0, your unity will drop immensely, and with drop in unity, the chance of a breakup of your army is higher. If your army size drops below 2, then it's game over. So there's a constant force to push to the east to get to the next red line. Once you reach a red line, this red line disappears and there will be a new red line at the same distance to the east. For my field of view algorithm, I kept it very simple. I was looking into more complicated stuff, especially for hex tiles, but I wasn't really satisfied with any of the solutions I found. You can see here the dense forest is blocking my line of sight. So in a dense forest you will basically see nothing. Right now there is no fog of war, but in the final game you will be basically blind in a dense forest. So the algorithm is pretty straightforward. There is a maximum radius and a minimum radius. Some terrain like hills and mountains increase the minimum radius. That means line of sight will always be, at least in these examples, 3 or 5 tiles. And what I do in this algorithm, it's a nested loop which runs through all tiles in the maximum radius. Then there are some special cases the tile I'm standing on, and tiles that are lower than the min radius automatically get lit up. Everything outside the max radius will not. What I'm doing is I go basically pixel by pixel. So I translate the position of each tile to a pixel stored in POS, and then I go with a step size of 1 pixel along a line to the tile I want to check the visibility on. This is not very efficient. I could increase the step size and probably will, because my tiles are 128 by 128, so 1 pixel really is a super small size. But this calculation doesn't take a lot of time, and the lower the step size, the more precise it is. So that's it for my first devlog, and I talk to you in a week.